Welcome back everyone, Patrick here, and moving on to the next example, we got to find the slope of the tangent for this function f of x equals square root of 3 minus 2x at an x value of negative 3, and we got to find it using both of these definitions right here. So like we did in the previous video, I'm going to first show you how we get the answer using the first definition and then get the exact same answer using the second one. So with the first definition, we got the limit as h approaches 0 of f of a plus h minus f of a all over h. And what's the a value we're working with in this case? Negative 3. This is the function, and then that's the a value. So if we plug in that a value into that general definition, we'll have f of negative 3 plus h minus f of negative 3 all over h. So what we got to do now, what's f of negative 3 plus h going to be? Well, we would take this negative 3 plus h, this expression in brackets, and plug it in for the x. So we would end up getting 3 minus 2 times negative 3 plus h. That goes in brackets, this x here. Minus f of negative 3. Now what's f of negative 3 going to be? If we plug in negative 3 for the x value, notice we'll have negative 2 times negative 3, which is positive 6, plus 3 is 9, and then the square root of 9 would give us 3. And this is going to be all over h. And so continuing on, what we got to do now is simplify what's under the square root. So let's distribute this negative 2 inside the bracket. What would we get? So negative 2 times negative 3 is positive 6, plus 3 gives us 9, and then negative 2 times h gives us negative 2h. Yeah, so that's correct. If we distribute that negative 2 inside the bracket, simplify, we get 9 minus 2h under the square root. And then the negative 3 stays as is, and this is all over h. Now, what's the problem here with this limit? We got to get rid of this h because we can't plug in 0 yet. And so if you remember, if you have something in this format, what you got to do is you got to rationalize it. Okay, so what you would do is multiply this two-term expression by its conjugate, which would be square root of 9 minus 2h plus 3. You would just change that sign in the middle. But you can't just multiply this expression that we're working with by another expression. You got to multiply it by 1. Meaning you got to put that same expression, that same conjugate, in the denominator as well. Right? So it's like we're taking this, multiplying it by 1. And so now what's going to happen, if we continue up here, when you take two-term expressions, multiply them by and they're conjugates of each other, and you multiply them, you just multiply the n. So square root of 9 minus 2h times the square root of 9 minus 2h is just 9 minus 2h. And then negative 3 times positive 3 gives us negative 9. This is going to be all over these two. Let's keep separate. So we'll have h times square root of 9 minus 2h plus 3. And now notice how when we simplify the numerator, the 9's cancel out. 9 minus 9 is 0. So we'll be left with negative 2h up top, all over h, bracket, square root of 9 minus 2h plus 3. Notice these h's cancel out, and now we could plug in 0 for h. If we plug in 0 right here, negative 2 times 0 is 0, 9 minus 0 is 9, square root of 9 is 3, 3 plus 3 is 6. So we would end up getting negative 2 over 6, and if you simplify that, negative 1 over 3. And so that is the slope of the tangent for this function at that x value of negative 3. Now what if we use the other definition? So we got the limit as x approaches a of f of x minus f of a all over x minus a, and the a value we're working with is negative 3. So if we plug in negative 3 for the a in that definition, we got x approaching negative 3 we'll have f of x minus f of negative 3 all over x minus negative 3. You got to put that in brackets. And so now what we got to do is work with this limit here. So limit as x approaches negative 3. What's f of x? We would just write out the function as is. So we got 3 minus 2x minus f of negative 3, as we did in the previous definition, we showed that it's equal to 3. So this would be a minus 3 right there. Is that right? Yes, it's all good. All over x minus negative 3, which would be x plus 3. So we got to get rid of this x plus 3 because notice that we can't plug in this x value negative 3. It would make the denominator equal to 0. And so to do that, what we got to do is rationalize this expression. So we would multiply it by the conjugate of this, would be the square root of 3 minus 2x plus 3. We would just change that sign in the middle. This would stay the same. Remember, we don't change this sign under the square root. That stays the same. We just change the sign in the middle of the two expressions. This is an entire expression, the square root here. And then we'd have the square root of 3 minus 2x plus 3. Let's continue this here. So we got the limit as x approaches negative 3. When you multiply these two, you just multiply the ends. Square root of 3 minus 2x times the square root of 3 minus 2x is 3 minus 2x. Negative 3 times positive 3 would give us negative 9. All over these two, let's keep separate. So we'll have x plus 3 and then the square root of 3 minus 2x plus 3. Okay, so I'm going to erase this part here, give myself some more room, and I'll continue this up here. So if we simplify the numerator, notice 3 minus 9, those are like terms, that would give us negative 6. So we'd be left with negative 2x minus 6 in the numerator. And then these two, let's keep separate. So we got x plus 3, and then the square root of 3 minus 2x plus 3. Now what we can do is we could factor out a negative 2 in the numerator. So if we take out that negative 2, we'd have x plus 3 left, right? All over x plus 3, and then the square root of 3 minus 2x plus 3. So notice those two cancel out. And now we could plug in negative 3 for x because that factor went away. The denominator won't be 0. So if we plug in negative 3 here for this x value, we'll have the square root of 9. So we'll have negative 2 over square root of 9 plus 3. Square root of 9 is 3, plus 3 is 6. We'd end up with negative 2 over 6, which is negative 1 over 3. And notice that that is the exact same answer that we got when we used the first definition.